solid circular shaft of diameter d transmit at torque T, show that the maximum shear stress in the shaft is tau equals to 16T over pi d, I think it's cubed. Yeah, it's cubed, 10 max. Okay, let's begin. So I'll begin by rewriting the question. Where we have telling us that show that tau, which is the shear stress, equals to 16T all over pi d cubed. So we want to prove that tau equals to 16T over pi d cubed. So I'll begin by, we'll consider a circle. We'll consider that solid circular shaft. So I'll use a yellow maybe. So this is our circular shaft. Then this circular shaft will I'm not good with colors. Okay. Yeah. So I will consider this okay. So I will consider this circle. Then from here to here, then from the center to here, it's where we have our radius, R. So from here to here, from the center we have R, then I think this circle is not circular enough. Okay, there. So we will consider an elementary strip. So from here to here we'll have X, then from here to over here. So this was our circle. Then we considered just a small portion of the circle, this inner portion, which is dx. Right here, dx. Then this small portion will be called dA, and dA will be our elementary strip. So let's go and say R, where where R is the radius, where R is the radius of the shaft, and this small area, this in blue, I will call it dA. So this dA is the elemental strip of thickness okay of thickness dx. So when we want to find the area, so we'll begin by finding the area of dA. The area of that small elemental strip, which area will be? The area will be 2 pi by x dot dx. Yeah, so that's the formula of area of dA. Then next we'll find the shear stress. The shear stress, which is tau x, which will be tau multiplied by x over r. So next we'll go next by finding the turning force. The formula for finding the turning force will be shear stress multiplied by area. So we know that our shear stress is over here. So the turning force will be tau multiplied by the area, and our area is this one over here. So it'll be 2 pi x dx. Yeah, that's x. Okay. Yeah. So next we begin by finding so let me write it well. So this is, it will be 2 pi tau now x times x will be x squared over all of this divided by r multiplied by this dx. Yeah. So next, after finding the turning force, we will find the turning moment. We'll search for let me use a different pen. Search for the turning moment. So the formula for the turning moment will be turning force multiplied by the distance will be turning force multiplied by the distance, whereby it will be 2 pi tau x cubed x squared multiplied by x. Now the distance will be x. So after simplifying, we'll get our answers 2 pi tau. Now will be x times x will be x cubed dot dx all over r. So after that, we go to find the total torque. The total torque, which will be, so we want to find the total torque, we'll integrate our function integrate we'll integrate that function between between 0 and r. So we'll take that total torque T equals to integration of, in terms of r and 0 of this function over here. So it'll be integration of 2 pi x cubed dot dx divided by, just a minute, all of that divided by r. So by the rules of integration, we know that 2 pi and tau will be out of the integration. Even R, we won't integrate these ones. So what we'll be integrating will be x cubed and dx. Not forgetting R and 0. So this is R. Yeah. So you know how we integrate now will be 2 pi. Okay. No. Now here will be, when we integrate, it will be 3 plus 1 over 3 plus 1 for those who have problems in integrating. So that's how we'll integrate. So we will get so let's go. So when we continue, we'll get that. Okay, let me find space. We'll get that equals to functions equals to yeah. So where there was x, you replace it with r. So that's how we integrate. So let's continue. Let's factor out, we'll get that. So here, these two will cancel. Okay. So these two will cancel with this. You will get 2. This r will be 1. This will be power 3. So we will get tau pi tau r cubed all over 2, but we know that r, which is the radius, is always equals to a half d, the diameter. So we know that radius is always a half the diameter. So where there is r, we will place a half d. So our equation will go as pi tau over 2. Now this r will replace it with d over 2, so and it's cubed, so we will add, we'll cube it. So when we open the bracket, we will get now this will be d cubed, 2 cubed is 8, so here will be 8. So when we do 8 times 2, we get 16. So we will be, wait. So we get that t equals to pi tau d cubed all over 16. So here, when you reach there, we will say that make tau the subject. So when you make tau the subject of the formula, this tau over here, we get that tau equals to 16t all over pi d cubed. Which is in newtons per millimeters. So guys, I think we have proven, yeah. So guys, I think we have proven the formula, which is over here. This one over here. think we have proven it over here. So that was actually 10 marks, if I think. Yeah, 10 marks. So again, thanks for watching.